Hello everyone, I am Jackie. I'm very glad to be here and introduce a new version of UPS board. Here, I have already assembled the UPS board to my Raspberry Pi 4 B plug, okay? And this board is not only support Raspberry Pi 4B, but also adds Type-C output. It provides enough power for your Raspberry Pi to make your Raspberry Pi still work while moving or something else. And its design is so smart that you can get rid of the trouble of a mass wire. The UPS can provide you with the operation of replacing the battery yourself, alright? But the battery, you need to purchase some high quality batteries. The bad battery may damage your stuff, okay? And the new UPS not only supports an independent RTC mode, we need a clock, all right, but also provide a column counter so that you can modify the voltage and the current during your system, okay? Via the system, you can write some program to detect the voltage. All right, and also you can obtain battery voltage and current information through I2C in the system. Combined with different programming method, you can inherit the power information into the system. It's also convenient to detect the state of your battery, which can be detected and warned through the program. It can use most of the 1860-50 standard batteries and full comply with the battery's characteristics in terms of the battery life. In addition, the power display provided on the circuit board is also very user-friendly. The illuminate LED light can quickly show the remaining power and support discharging while charging, okay? You can directly connect to the external power supply for charging. At the same time, the Raspberry Pi will not be turned off, okay? And there's something I have to say. Please install the battery carefully, because some of the ESD area in this power board, in the middle of the board, don't touch it, okay? If you connect the battery, do not touch this chip, because it may damage your board, all right? And we call that ESD warning. And there are some new features I have to tell you, all right? Let's move it up. You can see that here is the RTC module, all right. When you connect your battery, don't touch this area. All right, and this is indicator here, LED here, and this area is ESD warning area. All right, okay, and make sure the pogo pin is aligned to your Raspberry Pi GPIO here, and fix it. It's very easy to assemble. All right. You will make sure every pogo pin is against to the GPL pin on your Raspberry Pi. Okay. When you assemble the PCB board, do not put your battery in your slot, okay? Battery slot. Alright, it's done. And then, please pay attention to the polarity of your batteries. Insert your battery as a sign of the signature, okay? And put it here. Alright, everything is finished. Let's turn it on, okay? Just press the button. Oh, my battery is in low level, so I need to charge my battery. Please don't hook up your power supply direct to your Raspberry Pi, okay? All you need to do is to charge your battery from this port. Do not connect power supply to Type-C port, okay? So let's do it. It's a micro USB cable. I just connect to the UPS. You can see that there is a LED indicator is blinking. It means your battery is in charging, okay? And then next step, we need to help you guys to understand how to read voltage and current. And there are 4 LED indicators here. You can find out the charging states in our wiki. So I will post the link under below, okay? And this means your battery level is less than 25%, okay? Only one is blinking. All right. And how to read voltage and current from your Raspberry Pi operating system. First of all, you need to flash the latest Raspbian OS to TF card and boot up your Raspberry Pi. This is the first thing. And second, you need to make sure your Raspberry Pi connect to internet and update the repository's information and with command sudo apt/get opt minor get blank update. So I will post that command in next video, in next scene, okay? And make sure your I2C function has been turned on. you need to use sudo apt raspbian config to enable that function. Okay, let's move to my computer, and then I will introduce how to read voltage and current, and how to set up and check your RTC mode. All right. Okay, next step is to connect to your Raspberry Pi via a software called Party. It is a free software, so you can download from the internet freely. It's an open source software. And we're gonna to right click on the menu and press new session. And first of all, you need to find out what kind of IP address of your Raspberry Pi has. In this case, I have find my Raspberry Pi and use a 22 port and use a SSH protocol so that I can connect to my Raspberry Pi remotely. And I will change some size of font. Okay, let's make the font bigger so that you can see it clearly. And also I will change the background color so that it will be clear. Okay, and log into Raspberry Pi by Pi user, and my password is Raspberry. After logging in, you will see this command line, and all you need to do is to modify the command information from according to our website. Okay, we have wiki for the details to how to read voltage and current. Okay, I will paste this link below under the screen. Okay, in the description. And you know, we have several steps to solve this problem. First of all, you need to install the Pi INA 219 libraries in your system. It's also you can sudo pipe 3 install Pi minor INA 219. Please make sure your Raspberry Pi has been connected to the internet. Okay. All right. After installing, we use the INA 219 chip to read the voltage and the current as a Coulometer. Okay. I use vm.tiny. It's editor tools. I modify, create a new file named readvol .py. And first of all, we need to from IA219 library import IA219. It's a class. Okay. And then from INA219 import device range errors. If I encounter error, I can print the error. And we need to specify shunt ohms so that it's a constant value. And then I define a function use for blank INA equal to INA219. This command to initialize the INA object, and you need to configure it, make it enable, and you can read the bus voltage from this one. Okay. It means I will read the INA voltage, use this method to read the voltage and print it out. Okay, let's try except loop. It will catch the errors. Bus current means you can get the current from INA chip by this function. Oops, need more bracket. All right. And then print power. You can get power from this chip by this command INA.power. It's a function, okay? And then we can find shunt voltage. By using this function. Okay. Once we got the error message, we can print out, okay? We need the device range error. Pay attention to the capitalize, okay? Alright. And finally, we will define the main loop, the entrance. If name equal to main, we will execute the read function. Okay, save it, and let's try to read. But before that, we need to make sure our I2C function is enabled. So we can grab I2C from the /boot configuration config.txt. You can see the DT parameter I2C arm is on. If it's not enabled, please try to use this command: sudo respi config and select navigator to interface options. And then enable I2C in P5. Select yes. Okay, your I2C is enabled. It's the same as the grep result below. And so also you can use the I2C detect to check out your device is available. You can see that there are two register address here. The 40 is your chip on board UPS, and the 68 is your RTC module address. So if you see that, means that your UPS has been recognized by your Raspberry Pi. Okay, let's check out the read volt and PY. You will see the voltage and the bus current, and power shunt voltage, okay. And if you want to read this information continuously, you can modify your code. For example, you can add a while loop to read this function, and you can import sleep module from 10 modules, sleep function from module 10 libraries. And here is something wrong with the indent space. Okay, we need to use a space to run that. If you input the wrong indentation, it will be raising a tab error like this. So we need to use 4 blank, 4 space blank, okay? There's still something wrong with the indentation, so we need to modify it. All right. It will read the information in 2 seconds. All right, we can also add some delimiter. For example, we can print equal sign for 30 times. All right, you will get the information forever in 2 seconds, okay? And also you can write another application. For example, use PyQt or something else to build a GUI application, okay? And the next step is how to set up and check the RTC module. Some of you have can follow this instruction to check the kernel if it has already added the module of the I2C bus. So we use a mod probe I2C BCM 2835 to load the module. And if you use RTC DS1307, it may encounter some error because you have no permission to do that. It's a system level. So I use a sudo mod probe RTC DS1307 to load the module so that we can use LS mode to check if the RTC module has been loaded. All right, it's okay. If you want to enable the RTC mode permanently, you need to create a new device in your sys class folder. New device. Oops, we encounter permission denied also, so that we need to use root privileges to solve this problem. I tried to use sh and recheck this command. It's still not working, so that I use a sudo su command to change the operating user. I use root as my login user, and then I re-type this command again. And it will be okay. I have create a system file named new device, and then I have to add the DT overlay to my config.txt file in /boot/ okay. I use VM tiny tools to modify the boot config.txt file and find a place to put my parameters in. DT overlay equal to I2C DS1307. Okay, and in order to enable this function, I have to reboot my Raspberry Pi. Okay, and you can also add an address. Okay, there is two different ways to solve this problem, and for Raspberry Pi 4B and is different from Raspberry Pi 3B. So after adding these parameters to my config.txt file, I remove the software fake HW clock. It's a fake hardware clock. So I remove it and modify a library. Just common 3 lines, okay? Common out. Use hash. Okay. We need sudo vm tiny library udv hw clock set. Modify this file and comma out 3 lines in front of the file. I press I and insert 3 hash sign. It means I have comment them out. Okay, I have pasted a picture in the website. Okay, after that we can reboot our Raspberry Pi. After that, we can show you how to check it. And right click, we restart the session. After Raspberry Pi is enabled, okay? We restart the session again. Okay, log in with Pi and Raspberry. Alright, let's check the clock. You can see that here is my system clock. And we can use the D message to grab RTC. You will find that the RTC module has been registered as RTC0, okay? So that it means your hardware clock is enabled. And we can check also check the system clock and hardware clock. In this section. Alright, and we can use a sudo hardware clock. You will find this. Here is my hardware clock from UPS, and you can compare with your hardware clock and your system clock. If they are different, you can use system clock to synchronize to your hardware clock. Okay. All right. Maybe there is something different from your hardware clock and your system clock. So if you want to modify your hardware clock, you can first to modify your system clock and then synchronize your system clock to your hardware clock. For example, if I want to modify my system clock, there is a digital here for you to understand what it means. It means M for months, D for day, capital M for minutes, Y for year, S for second. So today is 2000 and July 21, so I can use this number for the months. 07 means July, 21 means day of today, 12 means hour, and minutes I want to use 22, okay? And year is 2020. Point second, I use 0. All right, I have modified my system clock here, and then I use HW clock minus W to synchronize my hardware clock to system clock. So these two clock is at the same. It's the same, okay? All right. After that, the hardware clock is enabled and work properly. So you can enjoy your UPS, and hope you like the video, and you can subscribe it and join our GeekPie group, and we can discuss all kind of product issue or some new idea in using Raspberry Pi. Okay. Thank you. Thanks for watching, and hope everything is fine. Bye bye.